Yes, so I will share with you our journey of migrating an EHR data model from a legacy system to openEHR. The EHR I will be talking about is KISIM. We have been developing and operating KISIM for almost 30 years, so quite legacy. It is used in over half of the hospitals in German-speaking Switzerland, so quite a big company but in a very small country. KISIM is a comprehensive EHR that covers a wide range of modules, from patient chart, report writing, activity reporting for billing, to scheduling, care planning, and so on. So we have to migrate many different types of objects from legacy to openEHR, which is quite a challenge. I will talk about a topic that many of us are facing, that is how to migrate from a legacy EHR to openEHR. Most of us already have an EHR that may be quite old and not based on openEHR, with many different clients, like here, accessing the data through many different APIs. But what if we want to migrate our legacy EHR to openEHR? How do we get there? There are many different aspects to this migration. My talk will focus primarily on the migration of the data model. That's how I've structured the presentation. First, I'll start by explaining the interdependency between the data model and the software application architecture. Next, I'll describe the architecture and data model that we initially had in KISIM to provide context for where we started. After that, I'll outline our goal, that is implementing KISIM on top of openEHR. And once I've clarified this, I can move to the core of the presentation. That is how we are managing the transition from our legacy data model to openEHR. So, let's start with the interdependency between data model and software application architecture. An EHR is a complex system, a system requiring different parts and multiple layers to provide its functionality. Here we see a very simplified classic software application architecture of an EHR with the 3 levels of a data tier where the data of the EHR is stored, an application tier where the data is processed and exposed to the clients, and finally we've got the presentation tiers. These are the different clients through which users interact with the data. And each of these tiers handles the data using a different data model. Even the communication between the tiers, like here or here, is based on specific data models. I have tried to emphasize this by giving each data model icon a different color on this slide. We try to propagate a data model to the next level to avoid unnecessary transformations of the data. But often there are still differences between these data models. So there is no single one data model for the entire EHR, but there is a specific data model for each layer of the EHR. And during my talk, I will focus mainly on the data model that the middleware exposes to the API, that is the red and the purple data model here. So, with that clarified, let's move on to the architecture and data model we started with in KISIM. That's what I call legacy data model in my talk. We use a classic software application architecture in KISIM. Let's take a look at the different tiers, starting at the bottom. We do store our data in an Oracle database. We use different middleware products here, like an IIS, a GraphQL server, a Fire facade. And these middlewares expose different APIs tailored to the needs of the clients. And finally, we have different KISIM clients, such as desktop app, mobile app, quite a few different board applications and app for patients. And in addition, there are various third-party apps and services which connect to our middleware, primarily through Fire facade. So now let's take a look at the KISIM data model in the data tier. As I've told, we store all the data in a relational database, and we store all objects of the same base type in the same table. So we use only very few tables. For example, there is only one table for all the different types of observations and actions. If we go up one level, or even two levels, let's have a look at the QISIM data model in the API. Now, okay, that looks a little bit different than originally placed, but nevertheless, it's the API on the level here that I mean here. Our middleware offers different sorts of APIs, as I've told before. Here we look at the GraphQL endpoint, more specifically at the GQL schema, which defines observations in the GraphQL APIs. And the columns of the Oracle data observation table, which I mentioned before, have been mapped to GQL fields here. So you see, our product QISIM is just one EHR, one system, but depending on the level of architecture, it works with different data models. So that was our initial situation, our legacy architecture and data model. Now let's move on to our goal. Our goal, where we want to be in a few years' time, is QISIM on top of openEHR. We will still have our different QISIM clients and even more third-party apps. But they will post and fetch their data via an openEHR API here and store it to an openEHR CDR. So we will have one single API for all clients instead of the many different APIs which we have now. And we will have a common data model for all clients. Furthermore, third-party apps, we see here, might be more easily connected thanks to the availability of both openEHR and FHIR APIs. The data model used in the openEHR API is defined in the openEHR specification. Composition are important openEHR entities for posting and fetching clinical data, and these compositions conform to previously defined openEHR templates built on openEHR archetypes. Here we see such a simple openEHR template for BMI observations. So now I have shown you where we started, what the legacy QISIM data model looks like, and I've shown you where we want to go, what our goal, QISIM on top of openEHR, looks like. But how to get from one to another? This brings us to the main part of my presentation, that is the transition of the QISIM data model from legacy data model to openEHR. We will look at the transition from different perspectives. We'll start with the architecture. So, how do we get from our legacy architecture on the left to the openEHR architecture on the right? In this overview, both architectures looked quite similar. So one might think that the transition should be quite simple. But the similarity is quite deceiving. There are indeed some big differences. First, we have very different data repositories, and then both middlewares expose different or other APIs using other data models. So let's take a look at how the transition from legacy to openEHR, to QISIM on top of openEHR, could be organized from an architectural perspective. There are different types of migration. We decided for parallel operation, where the QISIM application stores the data collected up to a cutoff date via legacy APIs in the Oracle DB. And from this cutoff date onwards, the data is stored in the openEHR repository via the openEHR API. And this cutoff date does not have to be the same for the whole of QISIM, but can be done step by step for each module or even submodule. To better understand how this architecture works and what I mean, we need to have a look at how the data flows. And we will have a look at the data flow in two quite different situations. On the one hand, we will look at how the data of a single object, for example here, body weight observation, is captured or viewed. On the other hand, we will look at data intended for a large graph is processed. Here, the example of a patient chart. So first, we will look at how data intended for an overview is processed. Here is a screenshot of the KISIM patient chart. The rows show different objects. Service requests are displayed with a green cross on a green background, like here, for example, and each cross indicates when an action is required. Observations are displayed with a yellow box showing value and unit, for example, the pulse here, or the blood pressure, which has been measured here. Well, and time flows from left to right, as indicated by the hours here. So, now let's dive in through this KISIM patient chart, and let's have a look at where the EHR data is stored and where the repositories are. For this slide here, we're assuming that we made the transitions for all observation data from legacy to openEHR on May 1st at 9 a.m. in the morning. That's this line here. So, that means that all observations measured before 9 a.m. on this 1st of May are stored in the legacy database, here in this Oracle DBMS. For example, this body weight of 85 kilograms or this pulse of 76 per minute, which are stored here. Observations measured after 9 o'clock on this May 1st, however, are stored in the openEHR CDR. For example, this body weight of 85.5 kilogram or this pulse of 80 per minute. We see that not the whole of the module has been migrated. There's still something measured or done after 9 o'clock, which are stored in this Oracle DBMS. For example, this bedside blood sugar, which disappears on the right side here, or medication statements, medication given here or further on. So all the data displayed on the red background here is stored in the legacy database, and all the data displayed on the blue background here is stored in the openEHR CDR in parallel. There is not a migration that we migrate all the data from here to here. But if there is not a migration of the data, it means that both data have to be merged. So that's how we do it. This slide shows the role of the middleware in this merge. Now let's take a look at the entire process from the data request to the return of the result. I'm now a user and I want to see all observations of a patient for a certain time interval. So first, the client here needs to, the client sends the request to the API. The middleware adapts the request and sends it to both the legacy database and the openEHR CDR. Both repositories fetch the requested data, and what is important, because it's just a summary, in the patient chart you do not see all the details, you do not have to fetch all data points, but you only fetch the start and the end time, the value, and yeah, that's it, finally, the status too. Well, that's it. So both repositories send back the requested data using their own data model. They don't know there is another repository, but the middleware does. So the middleware brings the two results together, and the middleware knows which data point in one model corresponds to which data point in the other model, and finally, the middleware returns the merged data to the client via the API. So luckily, since we only need to merge a few data points per object for overview, this merging effort is quite limited. For example, for the patient chart, we only need to know the UID, start and stop date, value, and status of each observation, or action too. So all the many other data points do not need to be read or mapped for the overview. But now let's go on to the other situation. The other situation is how a user enters the data for a single object or reads the data for a single object, an object where we need to have all the data points of this object. So this again is the patient chart as the user sees it. As you have seen previously, the user has no indication that the data for this overview overlap a migration cutoff date here at 9 o'clock. I mean, it looks the same on the left side and on the right side, before and after 9 o'clock. This is because the data sources are seamlessly integrated into the user interface. However, if the user enters data, he sees a different now. In our previous example, as seen before, there is this migration at 9 o'clock. So if the user wants to enter these 85 kilograms measured before 9 o'clock, then this legacy capture form opens up. And this form stores the data in the Oracle DB. If the user, however, wants to capture the weight 2 hours later, after 9 o'clock, then this new entry form will open, a new app built on openEHR, and the data will be stored into this openEHR CDR. So here, the user sees a difference when he captures data or when he looks at detailed data. So, when the user looks at the detail of one specific observation which occurred after the cutoff date, then the client talks directly to the openEHR API. That's what we see on this slide here. And nothing is read from the legacy database, and nothing has to be merged by the specialized middleware we saw before. So now let's put all these both situations together. I'm now a user opening the KISIM patient chart. And KISIM was migrated from legacy to openEHR in the middle of the period. We see on this chart here at 9 o'clock again. So as we have seen, the query to retrieve the data is sent to both data sources, and the result is then merged by a specially designed middleware. If I now want to record a body weight measured before the transition to openEHR, these 85 kilograms here, then a specialized, then a legacy data capture app opens, and this app stores the data directly in the legacy middleware. It doesn't have to pass through this merging data middleware. On the other hand, if I want to capture weight measured after 9 o'clock, well, then another specialized or a new specialized app opens up. This one designed for openEHR, and it stores the data directly through the openEHR API. If I read the data, then the data is read directly from the corresponding EHR after 9 o'clock from this one, before from this one, and there is no merging needed. The merging is really only for the overview. So that's the fundamental difference between these two data flows shown in the diagram. For the overviews, that's the patient chart, but it's the same for the overview of billing or records or scheduling or whatever. That for the chart overview, we do only use a subset of the data points. Here, only UID, start, stop date, value, and observation status. But we need to merge these few data points coming from the two sources with some extra middleware here. On the other hand, for capturing a new data object or for having a detailed view of an object, we need all the data points of this object, but we can access this directly through a direct connection with the corresponding API, and we don't have to merge the data. Yeah, and we have modified our system so that each module overview opens either an openEHR or the legacy application for detailed view or data capture. So we can have a system with a legacy DB and an openEHR DB running in parallel. This allows a very smooth transition from legacy to openEHR. And this is where customers can hook in with their own apps based on openEHR too. Well, so that's how it looked like technically. If we now look beyond the patient chart to the transition of the other KISIM module, then we have an overview of the different KISIM modules here. Everything I've shown until now was regarding the central patient chart. And we see here we have a small part in blue based on openEHR. We still have some parts like the medication I've told before, bedside labs, and so on, still based on the legacy data model, so that's in pink here. And we haven't touched the other modules now, so they are all still based on the legacy data model, still in pink. But I have shown you before how we can start by migrating just one part of a module to openEHR and migrate other parts later. So we can apply this step-by-step migration to every KISIM module until finally we have migrated the whole system to openEHR. That is when everything is blue on the right side of these arrows. So that's it. I hope I've been able to give you an understanding of how we are migrating KISIM from legacy to openEHR. Thank you for your attention.
Do we have any questions? Plenty. Okay, that's great. We've got just 2 minutes, so be short with the question and the answer.
Thank you. Very interesting. Quick question. Do you plan to ever decommission the Oracle side? And how do you plan to do it? Then you would need to migrate all the old data to the new one.
No. We don't have to migrate everything. I think first we have this parallel operation. But the question is, how long do you need structured data, and to which degree does it need to be structured? I think you have a big part of this data which you can just transform to BDFs or whatever, which might still be usable if you want to go back. Further on, we have other systems, not shown here, but in the back. We have other repositories where we normalize all the data for analysis, and there this one might still be there for the future if you really need structured data. So we will not need to transform everything, perhaps just selected data points.
Thank you. One more question?
Hi there. Yeah, two questions. First one, do you see any loss of performance in the middleware? And secondly, the cost of the additional hardware infrastructure for your clients, has there been any pushback on that for the additional database?
Well, yeah, good question. That's what we are working on. Of course, our system has been optimized for 30 years, optimized for performance. And that's what we are doing now. We have a lot of different customers, 30 different hospital groups in Switzerland. They are not buying all the same openEHR repository, so we have to see with each of them how we can reach our goals, how we can meet the performance we do have to meet. We are still working on this. We will be able to attain this, but it needs some special adjustment to the queries and indices. Until now, we could do it ourselves in our legacy system. Now we have to cooperate with the openEHR CDR providers.